Hello and welcome to our step-by-step guide on precision geotagging using Emlid Studio. Today we are diving into the world of drone mapping to ensure your images are perfectly synced with PPK data for unmatched accuracy. Geotagging drone images with precise coordinates is crucial for professional mapping, surveying, and 3D modeling. And when your image count matches your PPK points, you know you are set for success. Emlid Studio stands out as the tool of choice for this task, thanks to its user-friendly interface and powerful processing capabilities. In this tutorial, we will be taking a case where image count and PPK points are matching. We may come up with two more scenarios where either PPK or image count is mismatch. And in coming videos we will take up those two cases as well. That's a bit tricky, but for now we will proceed with a scenario when image count and PPK points are matched. Before we start, ensure at the time of the flying that your drone and camera are correctly configured. It's essential to sync your camera shutter with the GPS time to capture the precise location of each image. Also, don't forget to set up your drone to collect PPK data alongside your images. This data is key to our geotagging process. Now let us see how the data looks like post drone survey. Commonly, you will have base data, rover data, and raw images. Also, it is really important to save height of the antenna of the base. Let me navigate through the sample data. Let me open an image and show you its property. Okay, get info. Here it is. And here we can see there is no location details. And now we will come back here once the magic completes and we will see what we will get after our process is done. So with your images and PPK data ready, open Emlid Studio and create a new project. So here we go. This is our Emlid. We are using Emlid Studio 1.3. Versions may change, but the basic process is same. So here we will import data so that we can do the processing. Now let's go to the first option, that is drone option or the rover data. Either I can drag and drop here, or I can click this button. Okay, so this is drone data. Here we have two options which is popped up. That is one .obs, that is an observation file, and .ubx, that is a compressed version of all these files. Now let me take a brief moment and explain you about .ubx file. It stores raw observation from GNSS satellites, including information such as carrier phase, signal strength, and GNSS satellite positions. It is a compressed version of .obs, that is observation, .nav, that is navigation, and .pos, that is position find, that we have in this folder. You can see this. So when you select .ubx as input file here, what it does, it uncompressed these files, and let me show you. Um, you know, I have selected here. So it is converting the raw file to the Linux file. Okay, so what it does at background, it has uncompressed the data, which in the rover drone folder you can check. So this we got it. So what it does, it has given you the observation and position file. Okay, and in Emlid, if you see, it has automatically taken the file which it has recently created, and also it popped up the navigation file as well. Otherwise, if you don't have .ubx file and you want to select .obs file here, okay, so you don't see anything here in the navigation section. So here you have to manually select the navigation file. So I hope you understand the difference between the .obx file and the other way around to execute the same process. However, it is recommended to use .ubx file if available. So we will undo and we will select our UBX file. Okay. So why you say why you see this? Because it has uncompressed again and created a new file which is similar, and it has taken up that. So that's okay. That's not a problem. Okay. Moving on, then we go to base option. Click base and navigate to the base data, which is here. You can see observation file. So you need to take this file. Okay. So once you select it, you see a drop down here. Here I would bring your attention. If you have known coordinates of the base point, then you select lat, long, and height option from the drop down and enter the antenna details of height and base. So if I select C, I can select it manually. I can edit it manually. I can put the details here. However, if you don't know the coordinates, then you select the Reiner header position and it will take the values automatically. I go with this option. You can choose your option accordingly. Now enter the antenna height of the base here. Now since I know the model name of the base, that is RS2, so I will select RS2 and I will enter the measure height. Okay, I'll show you this. This is the antenna height. It is 2.634 meter. So I'm gonna enter this here. 2.634 meter, and I'm gonna save it. So you can select the best option for you and enter the height accordingly from the drop down. Now, as I told you, the navigation option, if you have uploaded .ubx file in rover section, then this file will automatically reflect here. If not, then click navigation and select the navigation file from the rover data. Now, upload MRK and RTK row. You can uncheck it. It is not required if you have used Emlid's Reach M2 or M+. But that completely depends on you. See, it says that RTK drones store timestamp of photo in a file with MRK extension. This file is not required if you use Reach M2 or M+. So it completely depends on you that you are checking or unchecking it. So now my data is uploaded and it is done. Okay. Before we hit this process button, I would like to take you to the setting page. Okay. Here it is important to understand the basic setting. So let's go through that. First one is filter type. This setting allows you to choose the type of filter algorithm that will be used for processing the GNSS data. common options are forward, backward, and combined. A combined filter processes the data forward and backward for more reliable results. It is advisable to select combined as a filter type, although it will take more time, but you can have a reliable result. So I am selecting combined here. Now moving on, the next important setting is elevation mask. This sets the minimum angle above the horizon at which satellites will be used in the processing. Satellites below this angle are excluded because low angles can lead to more atmospheric errors. It is typically set between 10 to 30 degrees and the default is 15 degrees. Let me explain you this clearly because this is very important. The elevation mask setting in processing is used to ignore satellites that are low on the horizon, which is important because the signals from these satellites are more susceptible to atmospheric errors and multipath issues. The recommended elevation mask setting is usually around 15 degrees, as this tends to be a good balance between excluding low horizon satellites with poor signal quality and retaining enough satellites for accurate positioning. If you are unsure of the best elevation mask to use, it's often safe to start with the default value provided by the software, which is commonly set to 15 degrees. It is important to note that the specific value of the elevation mask can vary depending on the geographic location and the environmental conditions during the survey. In regions with open skies and minimal obstructions, a lower mask may be feasible. However, in areas with significant obstructions such as urban canyons or heavy tree cover or high elevation buildings, a mask may be necessary to avoid using satellites that are likely to give poor quality signals. In summary, while the setting can be adjusted, starting with a 15-degree elevation mask is a common practice for PPK data processing, and you can adjust it based on the specific conditions of your area. Moving on, we have SNR mask. This refers to signal to noise ratio for different frequency bands, L1 or L2, etc. The SNR mask is the minimum SNR value at which the satellite signal will be considered reliable for processing. A higher SNR usually indicates a better signal quality. Let us spend some more time on this because this is really important. Finding the right SNR mask value for PPK data processing is a bit of a balancing act and often requires a trial and error approach. The general recommendation is not to use satellites below 40 decibel hertz to maintain a trustworthy fixed solution. Now, if you're getting a float solution, adjusting the SNR mask either up or down and observing the effect can help you home in on the best value. And lowering the SNR mask might include more satellites in your solution, but could let in bad quality signals, while increasing the SNR mask could exclude potentially usable signals. It's all about finding the sweet spot where the quality and quantity of satellite data used produce the best possible fix for your geotagging need. So here I go with the default 35 and 35, and you can go up to 40 because that is the advisable limit. So between 35 to 40 you can play around for the best possible solution. Now the next option is satellites. Here you can select the satellite systems you want to include in the processing. This can include GPS, GLONASS, Galileo, etc. And each system has its own set of satellites, and by using multiple systems you can improve coverage and accuracy. Here also I go by the default. Next is integer ambiguity resolution. This setting pertains to resolving the phase ambiguities of the GNSS signals, which is crucial for achieving high precision positioning, that is fix and hold. Fix and hold is a strategy where once the integer ambiguities are resolved, they are kept fixed to enhance the robustness of the solution. Okay, so I'm gonna go for fix and hold. For GLONASS and VBS, you have option to turn the integer ambiguity so resolution on or off. This is specific to the signal processing of each satellite system and affects how their respective data is integrated into the overall solution. The significance of these settings is to fine-tune the process of deriving the most accurate positions from the satellite data. So this is important when geotagging drone images because precise location information is critical for creating accurate maps and models from the images captured during the drone flight. Each setting can be adjusted based on the specific requirements of the environment and the objectives of the survey. So I'm gonna keep it as default, and these are my standard settings, and now I will save it. So once I'm ready, I'll click process. Now watch as Emlid Studio aligns each PPK point with its corresponding image using precise timestamps, ensuring each photo is tagged with the exact location it was taken. Here you can see the processing is going forward, and also I'm getting all the fixed results. Now it is going backward as we have selected combine in the filters, you remember. So forward, and it is again going backward, and I'm still getting all the fixed values. So there you go. Here we got all fixed, and total there are 566 image count. We can see it here. Okay, now I will show you one more thing here in the raw images. If you see, there are total 566 images. In here, 566 images. So our PPK points and the image count are matching. And also, you can see here everything is aligned properly. And this is the actual path the drone flew. And it seems very good. All the data, it's very good, excellent. And I'm satisfied with this. Also, I must tell you that a result shall come fixed value, and if it is not coming in fixed, then there is a problem. Then what you can do is you can go back, and tweak the settings what we discussed some time back and perform the activity again. This is tricky, but reality. It is really important to have 100% fixed for the accuracy and to generate photogrammetry models. However, if you are getting float percentage even after performing all the permutation combinations, then still you can go ahead for generation of photogrammetry models. But you will have to ensure that there is no single percentage. Basically, fixed means they are aligned relative to the base. Float means they are still aligned and within permissible range, and deviation is because of bad SNR. So tweaking SNR value will help a bit in this case. Yeah, let me just take a minute more and explain you fixed, float, and single in a better way. single means if here instead of fixed, if you're getting any single, or along with fixed float you are getting any single, then there is a problem. And single means that the rover has found a solution relying on its own receiver and base correction is not applied there. And precision in standalone mode is usually at the several meter level, which you don't want, which is a big no for any kind of post processing. Okay, so that is single. Now, what is float percentage? Float means that the rover receives the correction from the base but cannot resolve all ambiguities. And in this case, the precision is usually at the sub-meter level, which is acceptable. In some cases, it depends on the project to project. Now, fixed means that the rover, using corrections from the base, resolved the ambiguities in its positional calculation and achieved the solution with a centimeter level precision. And now let me show you the result of this. An event file is generated during the post processing of GNSS data in Emlid Studio. So I'll minimize this, I'll go to the drawer. Oh, everything is happening in this folder. Okay, so these are the two files which is generated as a result of the process what we did. This file records the precise moments when photographs were taken during a drone's flight, correcting each photo with a specific geographic location and timestamp. Essentially, the event file logs events where each event represents the exact time a photo was captured, allowing for the accurate geotagging of images with spatial data. And you will find this event file in row folder. Also, you can open this event folder in Notepad and you can check other details. See here, you will get everything, all the details. But for now, we're not going deep into this. So this is the result, what you will get. So now, with our PPK data ready, it's time to geotag. That is our goal. So once all the data is in fix, then click folder with photos here and navigate to the folder with drone images. So here we have our raw images. I'll just click open and I will update original photos. You can check or uncheck. I keep it unchecked. Otherwise, what will happen? It will, it will update everything on the original photos, which is a big no for any kind of, uh, which is a big no for these kind of activities. So I would want a new folder is generated with the updated information so that my raw images are intact. So I'm going to click tag photos. Okay, so it started tagging the image. So you can click show result files, but before that I'm going to show you something. Here in the drone rover folder, you can see a new folder is created, tag raw images. Now let me show you the geotagging details in image properties. So this image we had opened earlier, so I'm going to click and I'm going to go to the get information. Okay, so this was missing, so we performed this entire activity to get this here. Okay, so Now you can see location detailing image properties, which was missing earlier. After geotagging, it is crucial to verify the accuracy of the data. Emlid Studio allows you to preview the geotagged images and their locations on a map, ensuring everything is expected. So here I'm gonna tell you, a few methods. First method of verification is import geotagged images. Use GIS software such as QGIS or ArcGIS to import the geotagged images. These platforms can display the images on a map showing their exact geographical location, and you can verify it accordingly. Second method of verification can be, if you have a base map of that area, then overlay the geotagged images on top of a base map. Base map could be satellite imagery or topographic map that covers the same area. This helps in visually comparing the location of the geotagged images against the known landmarks or features. Also, you can check for the alignment. Carefully inspect the alignment of the geotagged images with the underlying map. Look for any discrepancies or misalignments that could indicate inaccuracies in the geotagging process. If not, then you are there and you got the perfect solution. Now, the third method of verification is if you have the ground control points from your survey area. Compare the geotagged location of your images with the GCP coordinates. GCPs are known point on the ground with precise coordinates, and they serve as benchmark to verify the accuracy of spatial data. So you can use the GIS software to calculate the difference between the geotagged image location and the GCP coordinates. And if there is a small discrepancy, that indicates a successful geotagging process. There are various other methods as well for verification. You can choose which suits you better. And there you have it, a complete guide to geotagging your drone images with precision using Emlid Studio. Remember, remember, remember guys, that accuracy is key in drone mapping. And with the steps we have covered today, you are well on your way to achieving professional grade results. And guys, if this tutorial was helpful, please like, share and subscribe for more tips on drone mapping. And if you have any questions or you want to share your experience, drop a comment below. Happy mapping. Bye-bye.